Alright, so this is a response video to a guy named Flat Earth Awakening, who's been having a bit of back and forth with Wolfie 6020 about some observations he's made from Perth, looking across at Bathurst Lighthouse and Wodgemup Lighthouse. This is actually a re-upload from earlier in today because I fucked up something fairly basic, so I pulled it down before anyone pointed out how silly I was. Anyway, so this is Bathurst Lighthouse. As you can see from Wikipedia, the tower height is 63 feet and the focal height is 98 feet. So 63 feet from the base to the top and 98 feet to the focal height, which I've put roughly here. Alright, so in between these two lines, it's about a sixth of the total, and this is 5/6 of the total. So we can split this 63 feet into 10 feet above the focal height and 53 feet below the focal height. And that obviously makes the total height of the tower above sea level 108 feet and the base of the lighthouse at 45 feet. Alright, so now that we have those two measurements, we can plot them onto Flat Earth Awakening's footage. Alright, so I've set 108 feet at the top of the tower, and on my PowerPoint slide, that is 5.27 centimeters from the top. The 45 feet level at the base of the lighthouse is 13.65 centimeters from the top of my screen. I've set the horizon, and it comes out at 15.20 centimeters. So we want to interpolate with our data points as to how many feet above sea level that is. Alright, so in Excel, I've put these two data points, so the number of centimeters from the top of the screen in PowerPoint and the elevation in feet. Excel has some pretty cool functions called slope and intercept, and these correspond to the gradient and the intercept in a line equation in the form y equals mx plus b. Alright, so if we run those formulas against these data points, we get our line equation, which is basically a scale that we can interpolate with on the image. So we can give it a centimeter mark on the photo and work out what elevation that is at the lighthouse, or we can rearrange the formula and give it an elevation to work out where on the image that should be. Alright, so as I said, the horizon is at the 15.20 centimeter mark, and that gives us an elevation of 33.35 feet. If you want to find out where sea level is, you plug in 0 as the elevation, and it will give you a point on the image, 19.64 centimeters. Alright, so where are those on the image? 33 feet is here, that's our horizon. 19.64 centimeters is actually off the screen, so that's where, off down here, is where sea level is at Bathurst Lighthouse. So that, first of all, we've got to see what the curve calculator would say to that. During Flat Earth Awakening's video, he actually pans out, zooms out, sorry, and we see this guy walk past. We're going to assume that he is about 5'10", average height, and we can stick two of them, plus a little bit extra. So I'm going to say his observer height is not actually 10 feet, I'm going to say it's 13 feet. Alright, so let's plug those into the curve calculator. He gave a distance of 12.548 miles. We've got a more accurate viewer height of 13 feet. And the refracted hidden it spits out is 34.59 feet. So we calculated 34.59 feet, and we measured it against the photo to be 33.35 feet. So I'm going to say that is pretty accurate. Well done, Globe. Alright, so now on to Wodgemup Lighthouse. Alright, so this is a still from his video. This is Wodgemup Lighthouse here. There are two rectangular square-shaped buildings over here that I have plotted using Google Earth coordinates into my ray tracer. I've drawn a black line as the horizon, and let's fade in my rendered image from my PovRay program. Let's see what it looks like. Alright, so as you can see, the elevation data is not very accurate. So I'm not getting this, this little valley here. So that's why I put in the buildings, so that we could scale this against the buildings. Here we go, so you can see that they line up. Alright, so do that one more time. Alright, that'll do. Alright, so this is the image. So you can see my horizon with standard refraction of 7/6R and an observer height of 3 meters is up here. The actual horizon in the photograph is a significant distance away from where I predicted. I'm not too concerned about that because if you look down here, see these little blocks? These are actually the bases of these towers and buildings at sea level at Wodgumup. So this is the 0 meters above sea level. But many people have been asking Flat Earth Awakening what his actual latitude and longitude coordinates are for this observation. And as yet, he has not responded. But he did give us an exact location to the meter as to how far he was away from Wodgumup Lighthouse. So what I did is open up Google Earth and use the circle tool to work out 29,073 meters, which is what he gave in his video. And it works out to be this viewing platform called Waterman's Reef, I think it was. And the problem is that this viewing platform has an elevation of 6 meters, not 3 meters. So what I did is re-rendered that image in my ray tracer, and here is the result with standard refraction of 7/6R. Looks pretty good, doesn't it? So I'm going to say, without him providing any latitude and longitude coordinates for his observer location, I think he was probably on that platform, and that matches quite well. All right, good night.